Me and my jowa. Wah! Uuwi na siya. Uuwi na siya. Wah!
Ay, umari ko'y jowa.
One day when the sky is falling.
Hello, good morning class, and welcome once again to our subject ESci123, your statics of rigid bodies. And today will be our last meeting for this year. Why? Because next week will be your Christmas break. So finally, wala sa for now ang atong mga kastresan sa eskwela and anything. So you can just rest and enjoy Christmas with your family siguro or with your jowa. Wah! Okay. So, for this meeting, for our last meeting, we will also talk about our last topic for this module. Diba? We have talked about your structural analysis, and on the previous lesson that we have tackled about the first method in solving the internal forces of each truss. But how about we are only concerned on some of the internal forces of some of the members? Nga, dili nata necessarily mag-solve sa tanan internal forces sa each member of the truss, but you are only concerned sa probably usa or duha or tulo ka members anang truss. Then we have another method. Okay, on our previous lesson, we have learned the first method, your method of joints, and now we will be talking about the second method, which will be your method of sections. So for the goal of this lesson, we have to first what's goal aning lesson? We are aiming to learn how to solve those members of a truss, the forces on the members of a truss, using your method of sections. So, let us start with this principle. Diba? If a truss daw is in equilibrium itself, kung atong truss kay equilibrium, therefore, also, the internal forces in that truss is also in equilibrium. Okay, so take note, ana, kung equilibrium gani ang whole system, then internally pud ana nga system, it is also in equilibrium. Okay? Just the same principle sa kadtong ato na learn before, that if you have this member siguro, you have this beam, and there is a tension that is exerted in this beam, and since this one is in equilibrium, because we know that this force and this force should be equilibrium, they have the same magnitude but they are directed on the opposite direction. So kung musulti ta nga equilibrium ni, then if ato ni siya i-cut diri, nya, ato i-imagine nga na-cut kung tayo ni siya, so equilibrium says that if the system is in equilibrium, therefore, the internal forces are also in equilibrium. So, ana po na siya. So since ang kaniyatong member is subjected in tension, therefore, internally po ani nga material, this is also subject in tension. Ngana lang. And same also goes to our trusses. So, if you have this kind of truss, sabat no? Okay. So, same goes to this truss we have here. If this truss is in equilibrium, nga makaingon man nga equilibrium ni siya, because there is a 1,000 Newton of force that is exerted here, and since nakapin support siya dere, So therefore, pwede na siya mutuyok, paingana, but it is restricted by this roller support you have here. So this one is in equilibrium. Again, ang pasabutan ng equilibrium, stable siya, wala siya naglihok. Kaya kung dili na siya equilibrium, probably nagtuyok niya ang atong truss. Okay? So, if this one is in equilibrium, therefore, if I'm going to create a cut right here, and we will expose the forces right there, then the principle that we have learned earlier just basically says that there are also equilibrium nga mga forces dira sa sulod sa atong members internally. Okay? So therefore, by using your equilibrium equations that we have known already, which is your summation of forces along the x, your summation of forces along the y, and your summation of moments about any point is all equal to 0. Okay? We can apply this equation in solving this problem, in determining the internal forces of these members right here. And if you're going to observe siguro, nag-solve ni mo aning tulo, nya, sige daw, ako daw ni i-try og method of joints, kinakibaw naman ko itong method of joints. Then, you will arrive on the same answer. The difference is, sa anila nga method, you can only solve for these three unknown nga forces. Dili para sa atong method of joints nga ato isolve ang tanan forces each member. Pero aning method of section, again, we are only solving for selected members only. Okay? Nga na lang. So, let's take this one as our first example daw. We have ato ibalik og kuan, ato ibalik og draw. So we have this truss and A, B, C, D, E, F, G. Okay? And ang gipangayo lang sa atong problem is to solve for the force in BC, CG, and GF. Okay? So, mao lang ni ang gipangayo sa atong problem. Selected lang members ang gipangayo sa atong problem. Ang atong member BC, which is this one, this member right here. Ang member CG, which is this one. And ang atong member GF, which is this one. So again, for us to be able to solve this three members, instead of using method of joints, kung maggamit ng method of joints, we can use method of joints by solving this one first, and then naka sa joint B. So, masolve na nimo ang C, ang BC. Pero wa pa nimo masolve. Kay, again, mag-joint na pud ka diri to solve your CG and GF. Which is, okay siya i-solve, pero it will take longer because you have to solve for some unnecessary members nga dili na kailangan sa tong problem. So, the better option for you is to use your method of sections. And again, by method of sections, all you have to do is to choose which members you are going to cut. And now, how are you going to choose the members you are going to cut? What are the rules that you should take note para mupili ka kung unsa imong member nga i-cut? So, kani, always take note, dapat ang imong ipili nga i-cut, muagi lang siya og kanang mga members nga at most tulo ang iyang unknown. Okay? Take note kay kung tulo ang unknown, therefore you will also require 3 equations. Ang kanang 3 equations nimo magamit nimo na diha sa atong equilibrium equation, right? So, sige. So, kumukat na gani kag upat ka anon, then dili na siya advisable. Okay? Dili na ka makasolve sa problem. So, in this case, if we are looking for FBC, for FCG, and for FGF, how are we going to cut this beam? In that case, magsegmenta 1, 2, and 3. Okay, so pwede na. And this is your section AA. Now, ang ato bang section AA, nag-cut ba siya og at most tulo ka unknown? Tatanawon. Wata kay baw sa BC, so usa ka unknown. Wata kay baw sa CG, usa ka unknown. And wa punta kay baw sa GF, usa ka unknown. So therefore, kaning atong section AA is only cutting 3 unknowns. Okay? So, we can solve BC, CG, and GF in this case. Kung tagaan kag problem nga, ang iyang gipangayo kay AG, BG, ug BC, then, imong pagkat kay paingani pod. Di ba? Kay usa, duha, tulo. And again, you can still solve for these 3 unknown nga mga internal forces of those members. But in this problem, we are asked for this 3. So, dito ta. Dili ta maging ani og cut kay dili man matubag ang atong CG ug GF. Diba? And now, next step is, since karon nakapili naman ta kung asa ta mag-cut, and this is your section AA. Karon, we have to choose which side we are going to choose. Sige, left aning section AA or right aning section AA? Ang ato button karon is to solve both sides. Okay? Para mas mahasa mo. And first, let us choose the left side. Sige. So, when you are going to choose the left side, all you have to do is to erase this one. Okay? So, ang nabilin, mo ni, nga members. B, C, C, G, and GF. Okay? And we are looking for these forces. And take note, always, again, we should assume our forces to be in tension. This is your FGF. This is your FCG. And this is your FBC. Nigara naman na, eh? Okay. So, now, again, to solve this one, we can use our equilibrium equations. And how can you solve this one using your equilibrium equations? Then, it's best for you to choose that equation nga dili magdubli og unknown. Kay, di ba, makahimo kag equation nga usa lang unknown, therefore maka-answer ka dayon sa problem. And dili na ka mag equation 1, equation 2 kay libog as much as possible. But if there is, kung walay chance nga ana ang mahimo, then you should use equations 1 and 2. Okay, sige. Let's say, for example, we want to solve FGF first. Okay? Solve FGF. Sige, unsa may maayo nga equilibrium equation na to gamiton para isolve ang FGF? Can we use summation of forces along the x? We can use summation of forces along the x kung ato na summation of forces along the x. Naatay FGF plus FBC plus FCG cosine 45. So, tuloy ang mga unknown ani, which is not recommended for you to solve kay mga equation 1 na pud gaani. How about you are going to use summation of forces along the y? 0 ang FGF and ang summation of forces along the y, right? So, may mayo gamiton. Now, take note. These two, FBC and FCG, as you can notice, they will intersect at one point. And kaninga point mo ng atong C. Diba? So, therefore, kung mag-moment ta about this point, ang atong FBC and ang atong FCG will both cancel out. Okay? And then, mabilin ng atong FGF. Diba? So in order for us to be able to solve for FGF, we can use summation of moments about point C. And let's assume that it's going counterclockwise. Okay, so cancel ang FBC ug FCG kay Muigo man sila sa atong point of moment. So therefore, take note, ato i-include ang external ha. Pero ato unahon ang kaning force FGF. FGF, moment arm of 2 meters. 2 meters is sila tanan ha. 2 meters, 2 meters. Tanan mga vertical ug horizontal members are 2 meters. And then, this one also creates a counterclockwise, so therefore this is plus 1,000 newtons multiplied by, diba? 2, 4. So 4 meters is equal to 0. So therefore, your FGF is equal to negative 2,000 newtons. Since this one is negative, therefore, we assume this one is tension right before, but since we have arrived on the answer of negative, so we should change that one into 2,000 newtons, and this one is in compression. Okay. So, ato ibutang sa tungkuan. FGF daw is equal to 2,000 newtons compression. Okay. And now we have solved this one. We have solved that one. And we are again asked for FCG and FBC. So, asa may sunod na to, pilion nga kuan, unknown. We can use FCG. Kaya diba, sa to pag summation of forces kaganiha along the Y, FCG ray makount, okay? Na siya vertical component. FBC and FGF has no component along the Y. So, we can use summation of forces along the Y to get FCG. So, to solve for FCG, summation of forces along the Y going up, kay up man atong kuan, equals to, this is 45, kay diba, 2 to 45. So, that is what? Stilan. FCG sine of 45 degrees minus 1,000 newtons is equal to 0. So, your FCG DI is equal to 1,414.21 newtons. So, since this one is positive, so sakto ang atong assumption that this one is in tension. Okay? So, last, we are now looking for our FBC. And we can use either summation of forces along the X, kay diba, kibaw naman taaning duha. So, usan lang atong unknown, and we can solve summation of forces along the X. Or, we can also use summation of moments about point G. Kaya nga naman, kung mag-about point G ka, makancel imong FCG, makancel imong FGF, and then mabila ng imong FBC. So, it's up to you. Pero ang ako lang pilion karon is to sum the moments about point G. Ganun ka na ako gipili. Kay, mas safe siya nga answer. Why? Because, what if sayop ang kaning imong FCG? Or what if sayop ang imong FGF? Then, kung gamiton imong summation of forces along the X, masaya po ang imong FBC. Diba? Okay? So, smayoning, gamit tawag kaning mga given nga mga values. Summation of moments. Kasaba ba anang drill? Oy! Summation of moments at point G going there is equal to FBC, moment arm of 2 meters minus 1,000 newtons multiplied again by 2 meters. Positive yung atong FBC because it's rotating clockwise, and negative ang atong 1,000 since it creates a counterclockwise direction, equals to 0. So therefore, your FBC DI is equal to 1,000. Since this one is positive, therefore, we can say this one is in tension. Sige, ato ibutang tanan ni nga values. FCG is equal to 1,414.21 newtons tension, and FBC is equal to 1,000 newtons tension. Okay? So these are our answers for this problem. So we have now solved for the three unknowns. But, how about, diba ni, promise ko kaganiha nga, ato i-try ang both sides, ang ato i-try karon kay ang left side. How about ato na pod pilyo ng right side? Will it still arrive on the same answer? Let's check. Okay, again, we have created a cut right here. Diba? And then we already have solved the problem by using the left segment pa. But now, how about we are going to choose the right segment? Okay, ato sa draw ang free body sa right. So this is your free body sa right. And again, we assume that all the forces are in tension. Kasaba pa. This is your F, GF. This is your F, CG. And this is your F, BC. Okay? But, wa pa tanahuman. We still have external forces right here. Diba? As you can remember, this one is a pin support. So, therefore, we should solve for the support reactions. Ako lang nag-assume nga mga directions of forces. Kay, yung ano ako direction, kay ako lang gi-assume. Okay? Kay support reactions man ni sila, dili man ni sila members. So kung members, ako i-assume kanon nga tension. Pero kung support reactions, I assume it at whatever direction. So this is your EX, this is your DX, and this is your DY. Now, inigtanaw pa lang ninyo ani. Wala daghanag anon eh. Mas nindot pa man siguro to gamiton ang pikas ang left. Definitely. So, therefore, you have to choose, kung tapulan gani ka nga tao, then you have to choose the easier way, right? So, kung tapulan ka, therefore, it's good for you to solve the problem using the left segment. Especially kung exam mo na na timer, so para paspas ang imong pag-solve, ang left segment ang pilia. Kung ikaw, kugihan ka nga tao and ganahan ka magpakalisod-lisod, then you can choose the right segment. And by choosing the right segment, you should solve for EX, you should solve for DX, and you should solve for DY. Okay, and let's do this one. Let's solve this one kay ako man ang pinaka-kugihan nga tao kay ako gisolve ang both sides. Diba? So, let's solve for this one. And observe if we can still arrive on the same value as we have on the left side. Kay dapat parehas silang value. Kay kung di, have to do it again kay basta natay sayop. Huy, matag wala lang. Okay. So, first thing to do is to solve first for the support reactions. But also take note ha, there are problems that wad you kay choice but to solve for the support reactions. Kay nigkat na usa ka support nga maapil sa pag-consider. Okay? Take note about that. Sige. Naglagsik-lagsik na akong laway sa kuwan. When you are going to solve this one, should we choose this system? No. Ayaw pilihan ka nga system, inig-solve na to sa support reactions. Kaya nga tong support reactions, nag-support siya sa whole system. Wala lang siya nag-support aning atong katunga. Di ba? So, we should choose this one. Okay. So, let's solve for the support reactions. Unsa may pinakadalian ni solbon? Ang dy. Sige. So, let's solve dy. Solve dy. By solving dy, what are you going to use? Summation of forces along the y. Going up kay up ang atong dy. Equals to dy. Sunod. Minus 1,000 is equal to 0. So, therefore, your dy is obviously 1,000 newtons. Okay, and that is going up. Okay? Next. How can you solve for your dx and ex? Nga, sige, di ba kay mao ni atong dx, mao ni ang atong ex. And we have these two forces only to solve for kuan. Can you use summation of forces along the x? When you use summation of forces along the x, duha ang unknown. So, the best solution is to use summation of moments. And to use summation of moments, you can either choose diri ka mag-moment or dito ka mag-moment. Pero I would rather choose the moment kung asay duha kabuok forces, which is ang nasa imong pin support. So, dira ko mag-moment. Summation of moments about point D going clockwise direction is equal to this one, which is your EX, moment arm of 2, and then this one, which is minus 1,000 times 2, 4, 6. So 6 meters is equal to 0. So therefore, your EX DI is equal to 3,000 newtons. And that is going to that direction. So therefore, by using summation of forces along the x, kibaw na ka nga wala may laing x component ani. So dx minus 3,000. 3,000 is negative because it's going to the left and your dx is going to the right, equals to 0. So therefore, your dx is also the same as your ex, which is 3,000 newtons. But in this case, your dx is going to the right. Okay, we have these values na. And we can just substitute these values right here para ma-erase na nato, para dako tag space. So your EY ay your DY is 1,000. Your DX is 3,000. And your EX is 3,000. Okay, erase. Asa naman po imong unahon pag-solve ani? Ay, hasol man i-solve, boy. Sige, ato unahon pag-solve ang GF. Solve GF. Again, to solve GF, dapat ma-cancel ang duha ka unknown. And we can cancel both unknowns by still using summation of moments about point C. Diba? So, summation of moments about point C, ang atong direction is dapat paing ana kay para positive atong GF, so therefore that should be clockwise direction. Equals to FGF multiplied by moment arm of 2, because this one is 2, 3,000. So that one is plus 3,000 moment arm of 2 gihapon. And then how about this one? 0 ang moment ani. Why? Because it goes through this moment point, the point of moment. So ang 1,000 ato yung butang. Sa man 1,000, this one creates a counterclockwise direction, so that is minus 1,000 times 2. And all of that is equal to 0. Okay? So calculating that one, your FGF should also arrive on the same answer of this one, 2,000. So let's try. I hope it will. Okay. So your answer sa GF is negative 2,000 newtons. And again, since this one is assumed to be in tension, therefore, we can say that this one is 2,000 newtons and compression. And we have the same answer as we have before. So correct na to answer. Next, let's solve for FCG. To solve again for FCG, we can use summation of forces along the Y. And going down para positive atong FCG. Equals to FCG. Let's say this is your 45 degrees. So that is sine of 45 degrees. And then, dirita, minus 1,000 newtons. O ano ba tayo lain? Kanira o kani equals to 0. So therefore, your FCG should also have the same answer of this one. And let's try. The answer here is 1,414.21 newtons. And since this one is positive, then sakto ato assumption, this one is in tension, which is also the same sa atong answer before, 1,414. Okay? So, sakto pa ta so far. And last, let's solve for FBC. By solving FBC, we can either use summation of forces or summation of moments about point G, which is this one. Pero, kaganihan nag-solve ta by using summation of moments. Ato na try gamiton og summation of forces along the X. Okay? Kani, ug kani atong ma-apil. So, ato i-show nga, padong dito, kay padong dito. Equals to, FBC, ato FCG kay tension, so, plus 1,414.21 sine of, sine ba siya? No, this is cosine. Cosine of 45. Next, FGF na to. Di ba ito FGF kay 2,000 siya pero compression, so padung unta siya dira. Ato assumption ganiha kay tension man to. So this is minus 2,000 plus 3,000 minus 3,000 equals to 0. I hope. And your answer right now is FBC is equal to 1,000.002519. And not a decimal because we have rounded this one off. Okay? So, na siya'y discrepancy gamay. So, it's better for you to choose the summation of moments kay mga exact values to imo ipanggamit adto. And we still have the same answer diri sa atong kani. So again, you can either choose the left or the right segment when you are going to solve for by using method of section. But again, the problem is that ang isa ka section mas taas siya og solution compared sa atong isa ka section. Then it's up to you if which section you are going to choose para mas masayon ang imong pag-solve sa ana nga problem. Okay? Okay? Gets? Understood? I hope you did. So, let's have another example. We have a truss here, and we only are asked for the internal force at member CF. So, how can we solve for our member CF? Again, instead of solving for all the members of this truss, we only ask for CF. So, it's best if we are going to use method of sections. But the question now is, how are we going to section this one in order for us to solve for CF? Ang una sa nato buhaton, ito sa i-draw ang free body diagram. Okay, so this is our truss. And again, we are only concerned for the internal force of this member right there. Okay? Mudiretso na ba tagkat, ani? No. Why? Because wala pa nato na account ang tanan mga external forces aning atong truss. Why? Di ba kay naa pa man tay support reactions? And we should also consider these support reactions. And we knew that our support reactions are exerting right here. This one is a roller support, so it only restricts your y direction. Let's call this one EY. And on your A, this one is a pin support, so therefore it supports both X and Y components. Now, question, is it really necessary for us to solve for EY, for AY, and for AX? Yes, it's necessary to solve, but not all. So, dili tanan aning nga mga unknown ang kailangan nato i-solve. Kaya nga naman, ato sa pilion, which side of the section are we going to choose? So, di ba, mag-cut man ta, and then sa paghuman na cut, magpili man ta kung asa ta nga side. Okay, and kung asa na to dapit ang imong gipili nga side, kadto ra nga external force ang imong pangitaon. Sige. So, di ba nga atong gipangita kay kaniman nga member? Right? So, what are we going to do? Di ba, sa atong rule, kailan ta mag-cut at least og tulo ka anon nga members. So, we can use this one as our section. This is your section AA. And now, second is, which side are we going to choose sa atong pag-analyze? Should it be on the left side or should it be on the right side? Again, sa imo pagpili, advice lang nako, pili ang gamay og unknown. Diri natay unknown nga ax ug ay. But actually, ay lang ang unknown diri. Kay ngano man, there are no x component sa aning atong truss. So, ay and ey. And probably sa uban problems na value ang atong ax. So, I would rather prefer diri sa atong right side. Sige, so ato lang sa karon pilion ng atong right side. So again, I'm going to draw the free body diagram of the right side. Okay, so mao na itong section sa left. And again, we expose these internal forces. Okay? And these are your FFG. This is your FCF. And this is your FCD. Now what? Diba? Napatay mga external loading. Ato'y appeal. Kay, GG jud ta. Marong jud daan ni kung di na to'y appeal. Diba? This is your 3 kilonewtons. And you have a support reaction of EY. But we don't know EY. So therefore, we should solve for EY. And we can solve EY by using summation of moments about point A. This is your point A, okay? And EY is ingana. So, therefore, your EY multiplied by the moment arm, which is 4, 8, 12, 16, minus 3 kilonewtons multiplied by 4, 8, 12, and minus 5 multiplied by 8 is equal to 0. Diba? So, therefore, your EY right here has a value of 4.75 kilonewtons. Musugot ba mo nga ang ani inyong grado? Of course! Kadakuan ang grado, di ba? Okay. So, this one right here is 4.75 kilonewtons. Okay. So, solve na nato ang support reaction. Now, the challenge is we are just going to look for your FCF. But the problem again is we don't know the 3 of this one. So how can we solve for FCF? If we are going to use summation of forces along the x, you can see that we have 1, 2, and 3 unknowns because all of these 3 have x components. If we are going to use summation of forces along the y, this one and this one has y components. How about if we are going to use summation of moments and kung dirita mag-summation of moments at point C, makancel ang CF. Diba? How about dirita mag-moment sa point F? Same. Makancel gyapon ng CF. So, unsa may pinaka-viable nga solution para ma-solve ni nato nga problem? Okay, let's think outside the box. Sige, char, di ba? Napatay think outside the box, di ba? Kanusa man makancel ang FFG ug ang FCD. Di ba? Makancel lang atong FFG ug FCD kung nagmomenta about anang ilang intersection. Kaya di ba kung mag-momenta diri nga point, makancel ang FFG ug FCF. Pero how about kung gana, ang atong ganan pilion nga makancel kay ang FFG ug FCD. So, ang ato buhaton, ato pangitaon ng intersection aning FFG ug FCD. Okay? And diha ta mag-moment para makancel lang silang duha and then mabili na lang is FCF. Right? Right. Okay. How are we going to do that? Well, of course, we have to create a line. Probably diha nang extend and then ato na po na-extend ang kaning FCD. Okay, and it shows that it intersects right here. But the problem again is we don't know the distance of this one from this base right here. So, ano ang gagawin natin? Okay, try go ta. Diba? Dapat ito gamit na itong trigo skills kay di dyan mo na ako pasaron dere kung di ninyo gamitin yung trigo skills. Di ba? This one is given. The distance of this one and this one is 2 meters. And the distance from here to here is 4 meters. And the distances of these one are 4 meters and 4 meters. With these information, what can we get right here? Tanawan eh. Di ba we can create a triangle from this one? Kani nga triangle. Di ba? And we knew that this triangle, sige ato na igawas nga triangle, makuntay ni nga triangle. Kani nga triangle, ang iyang height is 2 and ang iyang length is 4. Given 4 and 2. Right? Which is this one. And since this one and this one kadtong atong gi-extend kaganiha has the same slope, then we can use that equation, equal slopes, to get the length from here to here. Diba kay known man ni siya nga 2 ug 4, how about kung kani, which is ang given kay 6, 4 plus 2, 6, and then how about this length? Diba? Rise over 1 is equal to rise over 1. Same slope. So, 2 over 4 is equal to rise over 1, 6 over x. And then later on, we can solve for the x. And what is our x? That is the question. Our x is actually 12 meters. So from here to here, that is 12 meters. Okay? So take note. So, kanida ay diri, padong dito is 12 meters. Diri, padong dito, 12 meters. Okay? So take note of that one. And let's continue to solve the problem. Now, we have solved for the intersection of FFG and FCD. And we can now solve for FCF by using summation of moments. Summation of moments, and let's call the intersection of these two as point O. So summation of moments at point O, and given FCF going there, okay, is equal to. Diba, nakahinamdom mo nga, dapat perpendicular distance kanunay. But kani man siya perpendicular, what are we going to do again? Can you remember Varignon's theorem? That instead of having this one, we can use the components of this one. Diba? So let's use that one in solving our moment about point O. So una ta sa y components FCF. So that is FCF. This is 45 degrees, right? Because this is 4 meters and 4 meters. So therefore, that is cosine of 45 degrees. And the moment arm, which is diri padong didto, this is 12 meters. So 12 minus 4, that is 8 meters. Right? Next. How about this one? The x component, is this positive or negative? That is also positive. Plus FCF, and this one is cosine. This one is 45 degrees, so therefore we can still say that this one is cosine of 45 degrees. Multiplied by the distance, which is this one, which is 4 meters. And wala pa tanahuman, since kadto pa man tong components sa itong FCF, you also have to include these forces right here. So how about your 3 kilonewtons? Can this one be positive or negative? This one is also positive, plus 3 kilonewtons multiplied by the moment arm of, this is again 12, and 12 minus 4, that is 8 meters. And lastly, is this positive or negative? Of course, that is the other way around. Negative 4.75 kilonewtons multiplied by 12 minus 4 minus 4. So that is meters. Equals to 0. So therefore, calculating FCF, you can arrive on the answer of negative 0.589 kilonewtons. And since this one is negative, then we can say that this one is 0.589 kilonewtons, and that one is compression. Since this one, we assume this one as tension. Okay? So, we arrive on our final answer, 0.589. Compression. Understood so far? Understood this concept? Nga ato giing ani? Again, para makancel lang atong FFG and FCD. Okay? Understood? Let's proceed to our last problem. So for our last example, we have this truss. And this one is B and this one is E daw. The goal of the problem is to determine the internal force EB. To determine the force inside EB. And swerte kita karon kay gihatag na ang atong support reactions. So all we have to worry about is to solve for EB. Diba sign ra kaayo? Now, how are we going to solve this one? If ato to recall tong atong rule nga pagpili sa atong kuan pag section, ato daw ni gamiton og section. Yeah, ato mo himuan og free body diagram. This is here 1,000. This is your forces FED. Your force FEB. No. FEB. And FEF. And you are asked to solve for FEB. Can you solve FEB? If we are going to use summation of forces along the X, you have 0 value sa imong FEB because this is directed in the Y component. So, walay gamit. If we're going to solve this one on our summation of forces along the Y, how many unknowns will we have? 1, 2, and 3. So, wala gyapoy gamit. How about we are going to use moments? And probably, if you're going to use moments, you will sum the forces about this point. FEB will also be cancelled. So how are we going to solve for FEB? Probably siguro, we need at least one known either of the two. So kung nakahibaw ka ani, by using summation of forces along the X, you will also determine this one, right? And once you already determined both of these, then when you sum the forces along the Y, you can solve FEB. So therefore, before you can proceed in sectioning this one right here, you should first section some other parts in order to expose and to solve for either of these two forces right here. So let's say, for example, I want to solve for your FEF nga unknown. So how are you going to solve for FEF nga unknown? Can you use this one? Okay, so ingana tong cut. Sige, and let's say we have 3 unknowns. And we also have, don't forget, your external forces. This is 4,000 newtons. This is 1,000 newton. And this is 3,000 newton. Nindutag kwarta ni oy. Okay. And this is what we're looking first, FEF. And that one is actually, again, your FEF para ma-solve ang FEB later on. Sige, let's try. How can we solve FEF? Well, obviously, in this case, we can use summation of moments about this point, right? And this point is your B. Sige daw. Summation of moments about point B, and let's say the direction is going right there, is equal to what? Sige, gamit ang Varignon's theorem ani, kani o kana. Una ta sa X. This is tricky. Okay. So, una ta sa X components FEF. So that is FEF. And then, pilay angle ani. This one is 30 degrees because given there is 30 degrees and kanang kuan sila, si tawag ana, symmetric sila, so therefore this one is also 30 degrees. So, FEF cosine of 30 degrees. Moment arm of, pila man na ang moment arm. So, di ba we have this triangle right here? These are your members. B, nya, naadiri ang F, and then naadiri ang A. Okay. So, wala din eh. And they say that this one is 2 meters. So, therefore, this triangular there is 1. And this one is 30 degrees. So, anong malalaman natin dyan? Ang atong nahibawan is that opposite over adjacent. So, that is tangent of 30 degrees is equal to, wala takibaw, which is this one over 2. So, x is equal to 2 tangent of 30. So, ito butang. 2 tan 30. Next. Y component. Is this positive or negative? This also can create a clockwise direction. So, plus FEF, that is sine of 30 degrees. And then, moment arm of, that is 2 meters. And then, we still have external forces. At unahon ni, this is positive 4,000 multiplied by 4 meters. So, from here to here is 4 meters. Next, minus 1,000 times 4 meters. And last is minus 3,000 times 2 meters is equal to 0. So your answer sa imong FEFDI is equal to negative 3,000 newtons. So therefore, this one is 3,000 newtons and this one is compression. Since again, we assume that this one is in tension before. Okay? So, now, ano nang gagawin natin? Na-solve na ni nato. This is, ato ibali ang direction kay we learned that this one is the opposite. So, 3,000 newtons. Then, by using summation of forces along the x, we can solve FED. Now, take note. Di ba, sila raman duha ang unknown sa atong summation of forces along the x. We don't have any other x components right here. So, therefore, kung ingana gani ang case and then same na silag angle, then we can immediately say that by equilibrium equation, we can also conclude that this one is also in 3,000 newtons. Again, by using your summation of forces along the x. Kung inyo na isolve, you will still arrive on the same values. Ako lang nagidiretso kay tapulan ko and then plus para na mo'y dagdag kaalaman. Okay? Kugihan ko kaganiha, pero dugay naman atong lesson, tapula na pun ko. Okay? So therefore, we have solved for the 2. Kagets pa mo so far? And now, we can now solve FEB by using summation of forces along the Y. So, summation of forces along the Y going down is equal to FEB minus 3,000 pili angle ani? That is still 30 degrees, right? Minus 3,000 sine of 30 degrees. And this one is multiplied by 2. Ngano ako mag-multiply og 2? Kay duha man ni sila kabuok. Then, plus 1,000 as your external force is equal to 0. So therefore, the value of your FEB is equal to 2,000 newtons. And again, since this one is positive, so therefore, this one is in tension. So, this is our final answer. Taas guys, yung solution, no? Weird, no? But, that is our final answer. So, nga na lang kasayon. Nga na kasayon na itong topic karon, and I hope that you understood all of those solutions that I've shown you. So as a summary of this lesson, we have talked about the second method in solving the internal forces of the members of the truss, and we used the method of sections. And I hope that you have learned how to cut the members and how to solve for the unknown members. Okay? So, wala na itong lesson for this week, and we have finished our lesson for this year 2020. Dili pa school year. Okay? So, I hope that you enjoyed our topic, and I hope that you will learn this one until the end of your life. Kay importante kayo ni Char. And Merry Christmas to all of you. Merry Christmas. I hope that you will be happy. I hope that you will enjoy with your family. I hope that you will enjoy this time even we are in COVID. So, hope to see you again soon on January. And have a great Christmas, everyone. Merry Christmas to you all, and bye-bye. Bye-bye!